Welcome back to Smart Architectural Programming, your go-to channel for mastering the fundamentals of software development and architecture. So, what are we going to cover in today's video? We're going to discuss a very important topic. Again, it's part of our introduction to Java series and the start of chapter 9 in the book, and this is an accompanying video to that book. And we're going to cover important and one of the most powerful concepts related to object-oriented programming, which is inheritance and polymorphism. Now, you might have heard of it, you might have talked about it, but you're not sure exactly what polymorphism is and why is it important for you to learn it. We'll explore what inheritance means in Java, understand its advantages, limitations, and look at how it connects with polymorphism. By the end of this video, you should understand what a base class, subclass, and the crucial is a relationship mean in practical Java development. So, without further ado, let's push forward and learn about what is inheritance and how we can understand it. So, at its core, when we talk about inheritance, it's a hierarchy of classes and subclasses. Inheritance is a core principle in object-oriented programming that allows one class to inherit fields and methods from another class. It helps promote code reuse and establishes a natural hierarchy. As I mentioned about hierarchy, let's use the pen here and try to develop a little better understanding of what exactly it is. Let's get to a color that we can see more clearly. So, if we have a class called animal, right? I'm just going to use A to represent that. So we have a class called animal. Animal contains basically any animal out there in the natural environment, right? And similarly, how would inheritance work? How would we create a class called animal, and how would inheritance play a part in it? So then we can potentially create a class called dog or cat. Now, while they are separate to a degree, but both of them are also, if we think about it, animals, right? So the inheritance works like this. Dog and cat inherit fields and methods from the animal class and reuse them. As you can see in the screen here, we have a class called animal from 1 to 5, right? And we have a class called dog, which extends the class animal from 7 to 11. What does it mean that it extends the class? Using this extends keyword here, right? It extends animal in a quite simple way. What it's basically saying is take everything animal has and then add to it the blueprint of class dog, right? It's as simple as that. That's what you need to understand. As you can see, dog inherits from animal. This means dog has access to the eat function we defined in the animal, as I just mentioned right now, along with any new behavior like the bark method that we defined below. So we can use both eat and bark in the dog class that we're talking about here. And that's because it's extending upon the main class, which is animal. So that is basically in simple ways what inheritance is and how it works. So what are the advantages of inheritance? Let's break that down. There are going to be 4 key advantages here, and you just need to, get an understanding around them. You don't need to remember them, but you'll understand why this is important. So first of all, it's called reusability. And I'm going to check this off while I'm explaining this. So when we talk about code reusability, it is a common function. It's basically the common functionality of the code that is just written once. We only want to write certain logic and methods once, which means it means we don't need to write code over and over again. And this is one of the core principles of programming as well. Do not write the same code over and over again. So it makes sure our code is succinct, to the point, and we don't write the same logic over and over again uselessly. Then we have method overriding. It enables method overriding. What is that? It allows child classes to modify behavior of a parent class. So dog can modify certain behaviors of the animal class, or cat can do that as well. So that is something that you can do. Then it supports logical class hierarchy. What does that mean? It means simply it helps you structure code clearly. You know exactly how the code is structured and what is the logical hierarchy. I'm not sure if you're familiar with hierarchy, so let me put it this way. In a company, there's a CEO, at the right at the top of a company. And usually we build company hierarchies in a way that we tell you, hey, there's the CEO, under him is this director, and that director, and under each of those directors are further people in the chain. So that is a hierarchy telling who is at the top, who is under the person who's at the top, and who is under the person below the CEO as well, so on and so forth. So that is what we mean by logical class hierarchy. We understand exactly how the code is working and where it stands in the hierarchy. And finally, it can provide us with the ability to do easier maintenance, as changes in the base class automatically propagate throughout the code. So we just need to make one change or correct one issue or maintain one piece of code in the class, and it just corrects it across the entire spectrum of code base that we have. So we don't need to do it in multiple places, just one place, and we're done with the maintenance of the code. So that is why inheritance is a very important tool that you might want to learn and leverage. But with everything, there's certain limitations or constraints as well, right? So what are the constraints of inheritance? As you can see, we have 4 points here as well. So number one is tight coupling. So why is that an issue? So tight coupling between classes can reduce flexibility and increase risk during changes. What does it mean? So if one class like dog is directly linked to animal, and cat is also directly linked to animal, what would happen is that if the animal class has a major issue or a problem, it risks the entire code base having problem. But that is usually not an issue in most cases. What is even more important is that if we try to change the behavior of the animal class, right, in one specific aspect, then unintended consequences that could be that we're making certain behavioral changes, unintended changes to the cat and the dog classes, subclasses, which are inheriting property from the animal class. Then that creates problems. So that is something you need to be aware of when you're working with inheritance and object-oriented programming, basically. So then we have fragile base class problem. Now this seems kind of weird, right? Basically, this occurs when we change when changes in a superclass unintentionally break subclasses. So there's something related to the tight coupling I mentioned. When like animal class is tightly coupled to the cat and the dog class, in the sense that cat and dog rely on the blueprints of the animal class to work, as you mentioned earlier. What happened when I mentioned earlier as well, that if we make changes, there could be unintended consequences in dog and cat if we make changes in animal. Similarly, basically, if we make certain changes in the superclass, which is animal, what would result is that those changes might even break the subclass code, make it create bugs in that code. And that is a very important aspect to consider when you're working with object-oriented programming. You need to keep that in mind while you work with it. It doesn't tell you not to do it, but it tells you these are things that you need to keep in mind. These are constraints you need to understand when you're working with object-oriented programming and inheritance. Then we have reduced flexibility. What does that mean? So when used incorrectly, inheritance can lead to unnecessary complexity or misrepresent basically relationships, right? For example, when composition would have been better than inheritance. So some people I think basically forcefully use inheritance, and this point is related to both the reduced flexibility and misuse of inheritance point here, is that you become unflexible where when you try to focus on just doing object-oriented programming or just using these inheritance traits or things like that you start misusing it, and you reduce the flexibility of options you have. Inheritance should increase the flexibility of options you have to solve certain problems, not pigeonhole them to just one method. And that is what you need to understand with the inheritance, that you don't need to use it as needed. You can't misuse it because it would have you can create misrepresented relationships or problems in the code, that or unnecessary use of inheritance could create problems in the code that could be better solved with some other way. And flexibility, keep your options open. Inheritance is one tool in your toolbox. It's not the entire toolbox, and it's only there to help you, give you more options to solve problems, not just one option to solve more problems. So keep that in mind and you should be good. Now that we understand the advantages and constraints of inheritance, let's understand what base class and superclasses are. So generally speaking, a superclass is the parent class, like animal with dog and cat, right? It is a class that provides the inherited members with information, variables, data, and methods, right? In our example, we talked about the animal class earlier, but we're talking about, if you look at the code here, we're talking about the vehicle class here. So we're going over another example here. So vehicle is a superclass that we have defined here, which is for specific type, is superclass for any specific, basically superclass, but it doesn't define any specific types of vehicles like cars or bikes, right? As you can see, it says a vehicle, right? Anything that moves and transports you from here to there. It could be a motorcycle, it could be a car, it could be electric car or electric bike or a truck, or anything that moves you, right? That's a vehicle here. So that's the base class that we defined here, and you understand what base classes are. They're the superclass that gives the inherited members data and methods. So based on that understanding, now let's move to subclasses, and this example will be built further there. So when we talk about subclass, we need to understand this is the class that inherits the properties of the superclass, or it's the child class, that inherits the traits of the parents. And this it's also called the derived class. And basically, it can add its own method or override existing ones to tailor its specific behavior. But most of the blueprint comes from the parent class. You can, as I mentioned, you can write code or tweak behavior locally that extends only to that particular subclass or child class. But you can mostly use most of the behavior coming from the parent class. As you can see here, this is the car class that we've defined, extending the vehicle class. As you can see, car extends vehicle. Right, so that's another class that we've written out, and this is a unique function we create. Oh, messed that up, but all right. So now that we understand that, I think it's time that we go to a little bit more complicated aspect to it, which is the is a relationship. But it's important to understand this particular piece. A key takeaway is the understanding that is a relationship can be established between the parent and the child class. If class B inherits from class A, then B is a type of A. Let me say that again. If class B inherits from A is the superclass and class B is the subclass, we can define the relationship like this. A inherits, and you can build these useful diagrams when you're trying to map out these relationships, or by trying to build these relationships, because visualization would help you get a clear idea of it. So when class B inherits, anything down the arrow inherits, right? When class B inherits from class A, then B is a type of A. Right? That's the relationship you need to understand. Superclass and any child class is a type of the superclass. That's the basic point that you need to understand. Similarly, we discussed animal class earlier. So the cat and dog class is a animal. As you can see here, the dog class is an animal. Similarly, the vehicle, a car is a vehicle, which means a car is a subclass of vehicles, right? So based on this, you can understand that the relationship must make sense for the inheritance to be used correctly. And you need to visualize this and understand these terminologies and these visualizations to get good at this, basically. So we're coming to another important concept that we will discuss a little bit before we wrap up this video, which is polymorphism. So let's briefly touch on it. So polymorphism basically goes hand in hand with inheritance that we covered relatively in detail in this video. Polymorphism allows a subclass to be treated as its superclass, enabling dynamic method dispatch. It allows a subclass to be treated as its superclass, enabling dynamic method dispatch. What do we mean by that? You can see a piece of code here. We have animal A equals to new dog. We're creating a new object based on the dog subclass blueprint, right? And then we are saying it a.eat. Dog calls dog's version if overwritten, basically, of the method. Even though A is a type of animal, it refers to a dog. If the eat method was overridden in dog, it would be that version which gets called. That is the essence of runtime polymorphism. So that is what polymorphism is at this point that you need to understand. Runtime polymorphism is, as you had an animal, right? An animal has a dog and a cat as subclasses. And there's an eat in, let's use a little more understandable example. So the voice that an animal makes is any, voice, for example. We'll just call it noise for an example here, right? Any noise could be a voice of animal, and I'm not saying that in a literal sense. It's just an example to get you started. So there are multiple voices of animals, so we can just say noise is a depiction of all the voices that animals have, and that we have that as the value in animal. But within the dog class, we override that with a new voice method, and instead it says bark and the cat says meow, right? That means we have overwritten the voice in the dog class, right? And that is called runtime polymorphism. So I think we'll touch only that much in polymorphism, and we're going to wrap this video up. In this video, you've covered basically you've understood how you can use inheritance only when there's a true is as a relationship. You understood how you can favor composition over inheritance when appropriate. You understood how you can avoid deep inheritance trees, and you understood how you can use polymorphism to simplify code. To recap, use inheritance when there's a real is a relationship. Avoid deep inheritance chains when possible. Consider composition for greater flexibility. Use polymorphism to write cleaner and more scalable code. So with that, I think I'll be wrapping up. Thanks for watching this video of Smart Architectural Programming. If you're following along with our book, Introduction to Java, this video complements Chapter 6 on inheritance and polymorphism. Don't forget to like, subscribe, and hit the bell icon so you never miss a chapter in our Java journey. Got questions? Drop them in the comments. We love to help you push forward in the world of programming. With that, until next time, keep coding smart.